So going back to our airfare example, we want to find the least squares regression line, and then we're going to do all sorts of interpretations and talk about residual a little bit. Okay, so finding the least squares regression line, that's going to be using technology. So with that, let's go back to Staplet. I have everything still in here. This is still the distance and airfare data, my scatter plot, calculate correlation. The thing that changes is now we're going to click on calculate least squares regression line. And then it's going to be a whole bunch of information pops up. So what happened to our scatter plot is now we have an equation of the line in here. So we can see how that's matching up. We can kind of visualize our residuals as that distance between each dot and the line. There's that. Here's a plot of the residuals. I'm not going to go terribly deep into this, but if you think of 0, that's the spot where their residual is equal to 0, so where we'd be landing exactly on the line. So like this dot right here, we can see that distance 946, residual 138.39. That's coming from this one with distance 946. So where we have this furthest distance away from the line here, it's almost like we just switched the line to being horizontal and we can still see that large distance. It's just now it's kind of easier to see that vertical distance here. But we're not going to do much at all with those. Here's just a dot plot of possible residuals. We have negative ones, we have some close to 0, and then we have that one that's super far away. Again, not really going to do much with those at all. In fact, I'm going to go ahead and hide that even better. That's all I want to see. I just want to see the scatter plot with the equation of the line. And then some new information popped up here. So we have the equation of the line, n, that's our sample size, s, our sample standard deviation, we won't really use that. And then they actually give us r squared here, which is nice of them. Not too terribly difficult to calculate it, but sometimes that works nicely as output. All we want here is this equation of the line. So what I'm going to do is find the least squares regression line. I'm going to copy down y hat equals 81.7636 plus 0.137, and that 6 is going to round up that 2 to a 3. We can write it this way. Another format you might see equations in is where they actually put in the words for y and x. So like y is airfare, so what you could see is like airfare with a hat on top equals 81.7636 plus 0.1373, and then x would be distance. And that can be nice, especially as we're like plugging in predictions. You can see exactly what goes where. Either way is completely fine. Okay, give the slope with units and interpret in context. So, slope. What I do when I go looking for slope is I look for x first, because my slope is multiplying it. So, slope is going to be 0.1373. Now the units, and I kind of wrote this out on the previous page, y units per x units. So let's actually just rewrite this up here. X is distance, and the units for x is in miles, and then y is airfare, and the units for that is dollars. So if I think of it as y units per x units, that's like saying dollars per mile. So all I did there was take y units per x units. So my slope would have these units of dollars per mile. So give the slope with the units and interpret in context. So what I would say is y. So y is equal to the airfare. Slope is positive, so the airfare increases by, and then dollars 0.1373. I'm going to round that to, it's essentially 14 cents per mile. That'd be one way of interpreting it, or we could say for each mile extra we travel, the airfare goes up by 14 cents, but it's this rate of change. One little thing I want to adjust here is this sounds a little too matter of fact. Here we're estimating and we're using predictions. So I would want to say, maybe instead of starting the sentence with the, in fact, I'll write this in a different colored pen so we can see the correction. What we could say is we expect the airfare to increase by 14 cents per mile. Setting it as this is what we expect the data to do, it's not definitely going to happen. So we expect the airfare to increase by 14 cents per mile. All right, so there's our interpretation of slope. And again, where I started was for the units, I thought of y units per x units. So y units per x units. And then I just kind of thought of filling in the sentences here. Y increases or decreases by, and then our slope with the units attached to it. But we want to set some sort of that it's what's expected to occur. Okay, for the y-intercept. So we found our slope. Y-intercept is going to be the number all on its own over there. So the y-intercept is 81.7636. And this is the scenario where if x is 0, y is the y-intercept. So let's just fill that in. If x, which is the distance, if distance is 0, airfare is, and airfare is in dollars, so this would be $81.76. So what this essentially means is if we don't travel anywhere, or if a distance isn't set, we expect there to be a cost of $81.76. How I would interpret this is like a base charge. This is where all tickets start. They all start at $81.76, and then from there they go up. So how I would interpret this is the base charge for a ticket is $81.76. Something to keep in mind here when we go to interpret y-intercept, sometimes it doesn't make sense. I'm going to make a note of this so you can refer back to it. Because especially if you get a y-intercept that's negative, it might just not make sense. And it's because we're going too far outside of our data set. So sometimes it doesn't make sense and we can't interpret it. And that's totally fine. So even on a written assignment or anywhere where I ask you to find and interpret the y-intercept, if it doesn't make sense, you can just say so. The slope, you should always be able to interpret. Slope's going to make sense. It's just the y-intercept sometimes works, sometimes doesn't work. Okay, next up, estimate the cost of a ticket if they travel 200 miles from Baltimore, Maryland. So we want to find an estimate. So we want to find a y-hat, and we want to estimate that airfare. And what we're doing is we're setting x to 200 miles. So what we're doing here is we're going to use our equation of the line. So y-hat is equal to 81.7636 plus 0.1373. And then for distance, we're plugging in 200. And then from there, we go to a calculator, and that should be 109.22. And actually, let's go ahead and double check that because I'm grabbing that from an answer key where I'm second guessing myself a little bit. So grabbing those values, let's go to the scientific calculator. And I'm going to use a 0.1373 times 200 plus 81.7636. Okay, we're good. Okay, so making a sentence is we expect a ticket to cost $109.22 to travel 200 miles from Baltimore, Maryland. All right. And again, a key word in there is that we expect a ticket to cost. It isn't for sure, but that's our prediction based on the equation of the line. Okay, which airfare has the largest residual and what is the value of the residual? So this is a nice part of Staplet with that kind of interactive scatter plot is we can see the largest residual. And actually, let's go ahead and show that residual plot because this might be clearer even more so that would be our largest residual because that's furthest from the line. And then even clearer would actually be that dot plot because 0's right here and you're looking for what's the furthest from 0. So it's that 138.3839. I can't read that number, but that has the largest residual and that is coming from this point right here. So the clue they're giving is this distance of 946 and that matches up with our data value for Miami. So Miami. What we had observed for Miami was this coordinate of x of 946 and y, so the cost was 350. So then what we want to do is to evaluate the residual, we also need the predicted value. So for the predicted value, same x value, but the y is going to come from the equation of the line. So what I'm going to do here is go back to where I plugged in 200 and swap that for 946. So I'm seeing 211.65. So again, that number is coming from the equation of the line. This is coming from the data set. Okay, so to calculate residual, we take the observed value minus the predicted value. So for us, that's going to be 350 minus 211.65. So with that, we are seeing 138.35. A little off, but we're using some rounded values here, whereas Staplet is probably keeping everything really accurate. But being off at the second decimal place is not the end of the world. Okay, so if we wanted to interpret this, we would want to describe it as that our linear model either underestimated or overestimated. And something we talked about here, if we have our visual, is that what we're seeing for Miami was a lot larger than the prediction, and that makes our prediction an underestimate. So our prediction was below, so it makes it an underestimate. But you can also see that with the actual calculation here. So how we want to phrase this is like, for the ticket to Miami, the linear model, and then it's like we want to fill in the blank there of underestimated or overestimated. the airfare by, and it was $138.35. So even from the equation here, if you're writing out your work, you can see that it underestimated because our linear model's coming from P, and P was too small. So if it was a perfect prediction, we'd be seeing 350 and 350, but here the value coming from our line was smaller than what was observed. So the linear model underestimated the airfare by $138.35. So what that does, it also shows us the difference in cost between what we expected and what was actually observed.